What is the Fractional Reasoning Program? The Fractional Reasoning Program is an intervention for students, small groups, or can be implemented at the classroom or district level. When we hear the term intervention, we often think of a small group of select students, but as you'll see in a few minutes, the data does support for many schools a much larger intervention that reaches more students. The program is designed to support and be used alongside with your math program, not replace it. And the goal is to increase instructional time and strengthen and develop fractional reasoning. The program is designed to enrich and enhance fractional reasoning through supplemental instruction. This supplemental instruction will increase instructional time for fractions. The lessons and activities can be done in 20 minutes or less, and that includes the daily formative assessment. Let's take a look at this calendar. For the typical fourth grade class, the average fourth grade class spends between 8 to 10 weeks working on fractional concepts. Fractions will be taught through the traditional math series, and students will not receive any instruction for fractions until February or March. We then helicopter in, teach an intense unit of fractions, helicopter out, and students do not receive any more fractions until the following year. What the fractional reasoning program does is it allows teachers to methodically develop the essential skills before the traditional math program covers the content. Students Students are exposed to a variety of lessons and activities designed to develop their fractional reasoning. Teachers will notice that an investment of 20 minutes once or twice per week to supplement their instruction for fractions will help prepare their students for what's ahead in the curriculum. Teachers will also notice when they supplement, they have to spend less time developing concepts through their traditional instruction through their math programs. The fractional reasoning program is divided into three parts: diagnostic assessment, data based instruction, and student practice formative assessment. Let's take a closer look at these components. The first part of the fractional reasoning program is the fractional reasoning assessment. This assessment is designed to assess a wide range of skills from multiple grade levels across the curriculum. It measures basic skills like the identification of fractions from third grade all the way up through multiplying and dividing fractions up to sixth grade. After the assessment is completed, the progress monitoring section is filled out. This will allow teachers to pinpoint where the breakdown in curriculum is for each student and give them the essential data that they need for their instruction. This data will allow teachers to create custom target skills. Once a teacher has the data that they need from the assessment, the next phase of the program begins, making data-based decisions for instruction and focusing on the specific skills that need to be addressed. Every skill has a lesson card that goes along with the skill in depth. The lesson card breaks down each skill into teachable components, and every card has activities that are designed to address the deficiencies that the assessment revealed. Every activity has a short video that's less than 4 minutes long that shows teachers how to do each lesson. Once the activities have been completed, there is a short independent assignment that can be used as a formative assessment to give teachers fresh data to use each day so they can plan their lessons for the following day. So this is what the fractional reasoning program would look like in practice, okay? So this is TJ, and we're going to see a lot of him in a little bit. We're going to go through this entire assessment with him and some other students, okay? But these are the results of his assessment, and the assessment's broken into 4 domains: Domain 1, Domain 2, Domain 3, and Domain 4. We're not going to worry about what those domains are right now because we're going to learn about what each one is. But from looking at this, it's really obvious. We can pinpoint exactly where his breakdown in curriculum was, where he was able to get 100% on domain 1. And as soon as we got into domain 2, that's where his breakdown was. So we would go ahead and say, all right, we're going to work on domain 2. And then if you see there's 4 skills that make up domain 2, and obviously we're going to start at the first one, which is skill 7. So what we would do, we would go to the instructional materials and pull up skill 7. And what skill 7 has to do with is comparing fractions with the same denominator. So he had some misconceptions. This was a really hard skill for him. And the skill card is going to have some tips, right? Your teaching points, what you really want to emphasize when you teach. It's going to have some tips too. It's also going to go over some common misconceptions that students have. And then it says there's some formative assessments that you can give as well. So you'll go through, the skill card is more for you, for your preparation for the lesson. And then with every skill, there are activities, right? Some skills may have multiple activities, some may just have one. But you'll go ahead, you'll pull up the activity, it'll tell you what you're supposed to do. There's a little video right there. You click on that video, it's going to show you how to use that lesson mat and what you're supposed to do with it, okay? Then after you're done with the activity, you'll go ahead and you go to there is an independent assignment that it's supposed to go with every time you do a lesson with students, that they'll have sort of a practice piece that you'll be able to use as a formative assessment. And please take a look at this. So this says Skill 7, Activity 1. There isn't just one type of independent assignment for Skill 7, Activity 1. Don't think it's like, okay, Skill 7 is one day and that's all we're going to do. Skill 7 could take one day, it could take 1 week, it could take 2 weeks, depending on what the student. So there says Skill 7, Activity 1. There's one type of assessment here where it's assessing a very concrete understanding of what of comparing fractions with like denominators. If you take a look, another assessment or independent assignment where it's more abstract. It provides a number line. Students are supposed to plot where they go, and then they're supposed to make their comparisons. And if you take a look, there's another Skill 7 activity, independent assignment, where it's just the comparing of fractions, where they'll be focusing exclusively on what you're teaching about, focusing in on the numerator and so on. So even within each skill and each activity, there's layers of sophistication. And when you go through those activities, there's always going to be a part where it teaches or something in the concrete, then tries to go to representation and work its way to the abstract. So this is what an intervention would look like for a student who has a deficit in skill number 7, which is comparing fractions with like denominators. So before we get started, first we have to establish what is fractional reasoning or fraction sense, because a lot of people may not know that. So let's take a look right here where it says circle half of the set right here, okay? Now for us, all of us have some type of, I would assume we are pretty functional, rational thinker or fractional thinkers, or we have a pretty good sense of fraction sense. So when we say circle half that set, we look at this and we say, well, half that set would be 2. So, and this is just an example of 2 students. If you take a look at what Alex did, he circled half of each one of those individual. And we know that this was a whole set right here. So he treated each individual piece as a whole instead of the entire set. So technically he's correct where he has half, he circled half of each one, which equals 2. But does he even realize he did that? And obviously Cindy just looked at it and she said, okay, half of this set would be 2. Another example of fraction sense would be divide the candy bar into fourths. And if we take a look, this candy bar is already divided into halves, right? It's a whole candy bar cut into 2 pieces. So again, Alex may say, oh, if I'm cutting this into fourth, instead of treating this as a whole that's already cut into halves, he's going to treat each half as a whole and cut that into fourths. So he essentially put it into eighths, where Cindy was able to go through and cut that candy bar into fourths. Another example would be if we take a look at this, if Alex was given a 1/4 of a whole and said, go ahead and draw the remainder of it. If you take a look at the size of what a fourth is, and he just kind of sloppily went through and finished the fraction, okay? And then this one says, this is 3/4 of a whole. If you take a look, the partitions aren't there, but if we're saying that right there, that chunk is 3/4, he treated 3/4 like it was 1/4 and just continued to draw the fractional pieces and represent that as 1/4, okay? If you take a look at Cindy, this is 1/4 of a whole. She went through and she drew all of her pieces were even, and she continued and she completed the whole. And if you take a look at where it says 3/4 of a whole, she was able to sort of visualize that if this is 3/4, right, that's what that looks like. She was able to visualize that and then draw in that last piece. So the difference between Alex and Cindy is Cindy has fractional reasoning or fraction sense. And fractional reasoning, fraction sense means there's not going to be a procedure or a process that's going to help a student get through that particular part. It's how well do you understand fractions sort of within the context of one whole? How well do you understand benchmarks? That's what fraction sense is. So you're not going to be able to have like a procedure or a process to sort of bail you out and have you produce a correct answer. It's a measure of how well you know something. So now we're going to take a look at the curriculum for 3rd grade, 4th grade, 5th grade, and up to 6th grade. And no, we're not going to go through each standard, okay? But since this training is all about how to use the fractional reasoning program, obviously we're going to focus in on these standards that have to do with fractions. So if you were going to go through all of the standards, and I know you may come from a state that does not use the Common Core, but if you come from a state that doesn't use the Common Core, The Common Core still was sort of set as a standard where other states would go ahead and look at it and then create their own standards based from that. So if you're looking at the numbers we're about to go through, though you may not be a Common Core state, your numbers are going to be very, very, very similar to what we're about to go through. Okay. So if you just were to go through all of the standards and look what what is actually being taught in the grades, what does the curriculum look like? If you go through the third grade standards, 18% of third grade standards are fractions or rational numbers. Okay. By the time a student goes to fourth grade, it goes up to 40% of the curriculum is fractions or rational numbers, and by the time a student is in fifth grade, it's 58% of the standards deal with fractions or rational numbers. So you can look at it like this: from third grade to fourth grade, it doubles, right? From about 20% to 40%, and then from third grade to fifth grade, it triples. So the amount of fractions or rational numbers goes up each year, and almost pretty dramatically too. When you look at 20% of the curriculum to 2 years later being in fifth grade, it's 60% of the curriculum. So if a student is struggling with sort of third grade standards or even fourth grade standards, and they're struggling and they do not have a solid foundation of that, by the time they get to fourth grade and fifth grade, all these holes start to show up even more and more and more. So now what we're going to do is we're going to take a look at just a visual that sort of represents what's happening. And as a grade level goes up, the percentage of fractions and rational numbers also goes up. So now what we're going to do is we're going to take a look at some data to take a look at what's happening as the curriculum is changing, what's happening with student achievement. So what are the trends in the data? So we're going to focus in on Michigan because this is where we're from and we're really familiar with the area and we know where to get all the data. But just because we're looking at data in Michigan doesn't mean this doesn't apply to you, because the trends we're looking at are trends that are happening in California, in Pennsylvania, in Georgia, in Florida, and so on. So what we're about to go through is not unique to Michigan. This is just what's happening across the nation in school after school, district after district. Okay. So Michigan as a whole has 10 million people, okay? And we're going to focus in on metropolitan Detroit, which is this area right here, which a little over half the state lives here, and there's 5.5 million people here. It's the 12th largest metropolitan area in the U.S. And Michigan as a whole is not a diverse state. It's about 80% white and about 20% other. But metropolitan Detroit is a really diverse area. And so the white population is about 65%. In case you're wondering, the national average is 66%. Hispanic and Latino population is 6.2%. Black and African American is 22%. So the national average is about 13% for Black or African American. So our population is double the national average here. So there's a lot of diversity here, and that's why we're going to go through it. This is really representative of the nation, this small area. So what we're going to do now is we're going to look at some school districts, okay? Some are going to come from really affluent areas. Some are going to come from more middle class or lower middle class or working class areas. And some are going to come from economically distressed areas. And it's not that we're going to look at these schools and say, oh, look, the affluent areas are doing well and the economically depressed areas are not doing well, because we already know that's what we're going to see before we even look at the data, that those trends exist. But what we're going to look for are common themes in their data that has to do with fractions and rational numbers that go across all districts, whether you're suburban or rural or urban or in a high affluent area or in an economically depressed area. We're going to look at all the trends and common things that these districts have in common when it comes to fractions and rational numbers. So now what we're going to do is we're going to take a look at 4 different school districts in metropolitan Detroit. I'm not going to share the names of these school districts with you because the names of these districts truly is irrelevant. The goal of this is not to make one district look good or make another district look bad, because what we're really going to be doing is we're going to be looking at what are some common themes that all these districts, which are very different from each other, what are the themes that they have in common. So instead of the names of the district, what we'll provide you with is just the household income of the residents who live in that area. So one district is the household income is 122,000, another it's 106,000, another it's 67,000, and another one is 25,000. And we already know the goal of this is not to, a lot of people right now are probably thinking, well, what we're going to see are the affluent areas score really, really well, and the economically depressed areas don't score as well. And yes, that's what we're going to see, but it's not what our focus is on. Okay, and I'm just going to go ahead and kind of place these schools, and this is just kind of geographically where these districts fall. Just because it's by a city, for example, the 122,001, you could say, well, is that Farmington Hills or West Bloomfield? No, it's not. This is just sort of the area in which it falls. And again, we're not focused in on who these districts are. What we really are focusing in on is what does the data say, and particularly what does the data say about student achievement when fractions and rational numbers increase in the curriculum. So the assessment data that we're about to look at, this is called M-STEP data. Every state has their own test. I know in Texas they call it the STAR. In some states it's called Smarter Balance, or it's called PARC in some states. But ours is called the M-STEP. And just so you know, our cut score is around 70%-ish for proficiency. So that means that a student has to score, around a 70%. It fluctuates a little bit between grades to be proficient. So in our state, because we have a pretty high cut score, if you can have 60 to 70% of your students proficient, that's really like an elite score. I know some states may say, well, we have 85 or 90% of our students are proficient. That's the average. All that means is that you have a really low cut score. Some states, their cut score is 60%. Back in the early 2000s, or back in the mid 2000s, a lot of states, their cut scores were in the 50s. So most states have adjusted now where that 70 or close to around that 70%. But if you do come from a state where, 85, 90% is sort of the norm, it just means you have a lower cut score. So in Michigan, again, 60% to 70% of students is considered proficient, is considered to be a very elite score. The first district we're going to look at, we're going to refer to this as District 106,000. And it's an affluent community. People who move there, they're very proud to say they live there. They also are very proud of their schools. And so let's just take a look now. We'll go ahead and take a look. The economically disadvantaged is 20%. Non-white enrollment is 26%. And let's take a look now closely, okay? Let's take a look. There's our third grade proficiency score, our fourth grade proficiency score, and our fifth grade proficiency score. And just go from 15 to 16 to 17 to 18 to 19. You're going to notice one thing that is common all the way through. And the common thing we notice is in every single school year, right? Whether it's third grade through fifth grade, we notice that the score in fifth grade is always lower than the third grade score, all right? And it shows, almost like a loss of proficiency. And it's not that alarming because if you're taking a look, these third graders are different from these fourth graders are different from these fifth graders. What's more alarming when you look at the data is this. When you look at it as a cohort, so in 2017, this third grade class had a 67.5% proficiency. Then when those third graders were fourth graders in 2018, they dipped to 59%. And then in 2019, when they were fifth graders, it dropped to 54.5%. Okay. So a theme that we're gonna notice when we go through is as fractions and rational numbers goes up, student achievement goes down. The next district we're going to look at, we're just going to refer to this as District 68,000. We'll take a look. Economically disadvantaged is about 40%. So this is double the last district, okay? Non-white enrollment is 19%. And again, let's go ahead and take a look. And remember, we talked about, if you can get between a 60 or 70%, that's a really, really sort of elite score for a grade level to get. So if you take a look at, again, 2015, third grade, fourth grade, fifth grade, in every single one of these, you're going to notice the fifth grade score is lower, and in this district, significantly lower than the last district we looked at. There was a drop, but it wasn't as significant as a drop as it is here. And again, the alarming part isn't necessarily that these third graders were at 60% proficiency, the fourth graders and the fifth graders. Obviously, you want that number to be higher, but what's more alarming is this. When you follow the kids through cohorts, right? 2015, 60%. 2017, when they're fourth graders, they go to 47%. And then in 2017, when they were fifth graders. So the same cohort of students lost half their proficiency from 2015 to 2017. Take a look again, 2017, it's a lower number. But if you take a look, the trend continues, right? When those students go to third grade, to fourth grade, to fifth grade, their proficiency is dropping. And again, as fractions and rational numbers goes up in the curriculum, student achievement goes down. Okay, this next one is we're going to take a look at a district. We're going to call it 25,000. Economically disadvantaged, 87%. So almost 90% of this district is economically disadvantaged. Non-white enrollment is 95%. So we already know when we're looking at a district that has a lot of poverty, that's in in an economically depressed area, you know off the top you're already going to have lower scores. Okay, so let's go ahead and just take a look here, and then take a look as the curriculum increases with fractions and rational numbers, what's happening to achievement. And it really, if you take a look at this too, they start off with low achievement as it is. But by the time fractions and rational numbers are introduced, it almost falls off a cliff where they almost are at no proficiency. And Michigan will not report that a school was 0% proficient. So if you're either 4%, 3%, 2%, or 1%, it will report it as less than 5%. So this could be that 0% of these kids are proficient, which means they have no kids that were proficient by the time they're in 5th grade. Okay. So again, as fractions and rational numbers goes up, student achievement goes down. And this last one I want to go through too is this is probably, if you were to in the entire metropolitan area, if you were to say like, what is the top school district? Probably, there's a few pretty affluent areas, but this particular district, would come up in the conversations like a top 3 district. Okay, take a look. The economically disadvantaged students, 9%. Non-white enrollment, 20%. Remember, we talked about, between 60 and 70% is an elite score. So take a look. I mean, these are all over 60%, except for their 2019 5th grade. But everything else is all, in the 60 and 70%. But even these districts who have, who have all the resources that they need, children come from, homes where education is stressed, dually college educated parents, okay? High incomes, everything that we know that sort of gives kids an advantage in fraction, or not in fractions, but just in learning in general. Even these school districts, if we look at it from the cohorts as well, 69 to 60 to 57, even in really affluent areas where people say like, these are the school districts where districts will say like, oh, we need to go watch them and see what they're doing so we can do what they're doing. Even they are unable, even they have that same trend, they're unable to stop the slow drip of when fractions from rational numbers goes up, student achievement goes down. And if you think about what we just went through, right? It didn't matter if a school is in an affluent area or a working class or middle class area or an economically depressed area or even a rural area. The pattern is there, right? I'm not going to say every single school district has this pattern, but a majority of school districts, many school districts have this pattern where when fraction and rational numbers goes up, student achievement goes down. We would never accept this for reading. We say, yep, as our students get older, they become worse readers. There would be federal programs for reading, and there'd be a reading specialist in every school, and there'd be money flowing in. We would never accept it. But because we view math differently, and as a society, we just accept. I mean, how many times have you ever heard somebody say this? Well, I wasn't good at math either, so my kid's not going to be good. So we just kind of accept it. But there's a huge alarm going off. And not to be dramatic, but it really is almost a crisis because we know what part of the curriculum kids are struggling with, but we don't do anything about it. We just continue to do the same things over and over with small tweaks, and then we expect different results. So that's what this program was designed to do, is to tackle this issue head on, right? Fractions, rational numbers is the issue. Students need more instructional time. They need more experiences. They need better experiences. They need more conceptual teaching, not more focus on processes and procedures. So that's what the program is designed to do, is to tackle this head on by increasing our instructional time and giving students a chance to actually develop these concepts. And just some examples to show you what we looked at is not just a Michigan problem or a Michigan thing. I know that we were focused on Michigan, but this is a look at the 2019 PSSA, which is, in case if you're not from Pennsylvania, you won't know this, but this is Pennsylvania state test. And this is just state results, right? Just all the students who were tested. And if you take a look, everything is in line with what we just saw in Michigan, 56%, 46%, 45 or 43%, 39%, and so on. And every year, right, as fractions and rational numbers goes up, student achievement is going down. This is Georgia. If you take a look here, 53% for 4th graders, 53% for 3rd graders, 50% for 4th graders, 40% for 5th graders. And we know that as fractions and rational numbers goes up, achievement goes down. This is Washington State. Again, 3rd grade, they're at 57%. 53%, 48%, 48%. Again, the same trend that happens in Michigan, it's happening nationwide. And finally, California. Okay, California, this is they take the Smarter Balance test, and this is 50%, fourth grade 44%, fifth grade 38%, and so on. So whether you're looking at it from just grade levels or following cohorts, the same patterns are emerging. In the states we just looked at, California and Pennsylvania and Michigan and Washington State and Georgia, that's about 80 million people. So that's a really significant part of the population that we just viewed. So early fractional thinking is developed years before a child ever experiences a fraction like 3/4, and numeracy skills are closely related to fraction sense. So one thing is we're very reactive, right? We wait until we see data that says, oh, a child is struggling with fractions, now we need to try and fix it. But based off of the data that we just looked at, we can predict when children are in third grade, we know what they're going to struggle with going into fourth grade and going into fifth grade. So instead of being reactive, what our goal is to try to be proactive, right? And so fixing fractions has more to do with the things you're doing before you ever teach fractions than actually fractions themselves. I know that sounds really odd to say that, but you're going to see how strong numeracy instruction years before actually can help your fraction sense and your fraction problem. So it's not like we're being reactive. We're up there in fifth grade, we need to work on fractions. You're going to see how small things that you can do within numeracy can also help with fractions, fraction reasoning, and fraction sense. So as we just talked about, fractional concepts are developed years before a child ever sees a fraction like 3/4. So obviously today we're going to go over a lot of things you can do with fractions, but these are just some examples of things that you can do that can really be impactful. And if you commit to some of these early numeracy things, how it can help you by the time students do get to fractions so they're not struggling as much. So part of our K2 program has to do with children working on sort of Blake number lines to develop numeracy and number sense, okay? So what the activity is, you have a number line and it's blank, okay? And what this does, it teaches them about visual partitioning and where numbers would fall and helps with estimation and rounding and all these other skills, okay? But it also can be linked to a really important fraction skill, which we'll talk about in a second, okay? So there's a number line here and you'd say, all right, where would 3 go on this number line, okay? So students will go and, you'll talk and you'll show them, you'll say, where would 3 go? We think 3 would go right about here. And then you can go ahead and say, yep, this is where 3 would be, okay? So then you would go ahead and work on the numbers to 10, all right? Then after they're introduced to the 10 number line, you take them to the 100 number line. You say, okay, where do you guys think 3 would go? Now, a lot of students aren't going to count that. Look, there were only 10 numbers on this number line. Now there's 100 numbers on here. So students who are confused, they're going to go ahead and they say, I think 3 would be right about there because that's where they're used to 3 as being. They're treating these two number lines as the same, and they're not. So when you go through and you check and you say, you know what, actually, this is where 30 would be. So remember, instead of 10 numbers, there's 100 little, and even though we can't see them, there's 100 numbers on here. And so 3 would actually be over here. And then when you go ahead and transition to the 1,000 one, which would be more in second grade, right? And say, okay, where would 30 be? Again, a lot of students would put 30 right there because they're used to working off the 100 number line. And actually, we know that that would be 300, and that 30 would actually be sort of way over here. So if you think about what is this teaching students, right? This is teaching students about the inverse relationship. And this is something a lot of students struggle with fractions is the greater the number of parts, right? The denominator, the smaller each part becomes, okay? So understanding that, yep, you have 2 parts here, you have 3 parts here, and you have 5 parts here. And guess what? Even though this is 5, like as a whole number, right? 5, if you have a number line with 5 parts, those parts are going to be smaller than if you have a number line into 2 parts. And again, when you're working on fractions and rational numbers, what we're really doing is we're zooming in, we're focusing on the numbers between 1 and 2. So again, fractional concepts are developed years before a child ever sees a fraction like 3/4. So this is and this is just to show the links of numeracy to fractions and how, if you're thinking about it years ahead of time, it can really make an impact. So 1/4 of the primary numeracy intervention program has to do with something called developing the part-whole relationship. What the part-whole relationship is, it's about, decomposing numbers or breaking a number into 2 numbers. So, letting students work on a 10 frame and building 10 in different ways, 7 and 5, or 7 and 3, 6 and 4, in this particular one, it's 8 and 2, right? And then taking that concrete experience and putting it into a visual. Now take a look, what does this visual somewhat kind of represent to you, right? And then saying, well, the smaller the piece, right? The less space it's going to take up, so it's smaller the piece, and then the larger piece is going to be here. And then working into the abstract where students start working with digits, then understanding that, 8 is part of 10. So, if you know 8 plus 10, you can connect that to figure out what 8 minus something also equals 10. So using part-whole relations to develop all these concepts, allowing students to have, different models. And take a look. We know that this sort of looks kind of like a fraction model would. It's kind of, but it's not directly connected to it. Then when students go through the multiplicative thinking program, that has to do with students working with, groups and numbers of groups and so on with multiplication. And then if you think about it, in the primary program, they're breaking numbers down into two numbers, right? And when you're dividing what you're doing, you're breaking a number down into multiple units, right? It could be 2 groups or 3 groups or 4 groups of the same size unit. So we're breaking a number down, a larger number down into multiple units, right? And again, teaching the relationship of how that works, 5 times something is 15, 15 divided by 5. Going through with these connections between, a missing factor problem is a division problem, and that division is multiplication in reverse. So if you know 5 times something equals 15, it's the same type of thinking. When you say 15 divided by 5, you know you're going 5 times what is 15. So making all those connections, right? And then when you get into fractions and rational numbers, what are we doing? Well, you're breaking down, you know, numbers less than 1 and also numbers that fall in between numbers, like mixed numbers and improper fractions are just the numbers that fall in between 1 and 2 and 3 and 4. So if you think about it, now you're breaking 1 down into smaller components, right? And the greater the number of pieces you break it down, what happens? The smaller the pieces, okay? And again, take a look at the models here. We had a model here, we had a model here. Now, this is one of the most difficult things for students to learn, right? 2 divided by 1/4 equals 8. I remember being a student and being like, I don't understand how I'm dividing, yet I'm ending up with more. Now you can say, well, look, we have 2 here. What we're essentially saying is how many 1/4 will go into 2. And if we were to measure that out, it's a measurement division problem, you can go ahead and you realize, oh, how many 1/4 will go into 2? And it's 8. And again, the foundation for this is, yeah, this is a great tool, but if this is the first time they see something and you miss the opportunity to introduce multiplication like that, and decomposing or breaking the part whole relationship here, you've missed out on years of really those seeds being planted. Then by the time you get to fractions, all the models are the same, the concepts are the same. It's just a little bit more abstract and a little deeper learning. So now we're going to go over the 4 domains of the fractional reasoning assessment. So the assessment is broken into 4 domains. Each domain measures a particular set of skills. And the first one, this is the most important one. If you have students who struggle with domain 1, I can guarantee you they're not going to be able to do domain 2, 3, or 4. Okay. So domain 1, what it has to do with is the understanding a fraction within the context of one whole. You may say, well, what does that mean? So we're going to go through when we go through the assessment, you'll see, but this is a very this test goes very deep to make sure a child understands aspects of not just being able to name a fraction, but actually understanding a fraction, completing a fraction, having a little bit more than a whole, having a little bit less than a whole, and so on. So this has to do with making sure a student understands all aspects that a fraction exists within the context of one whole or in between wholes, okay? The next domain, domain 2, is comparing fractions with defined characteristics. Now, there's a big jump. Domain 1, a lot of kids will do really well with. Domain 2 is where you'll start to see students breaking down. This has to do with children paying attention to certain characteristics, understand the inverse relationship between denominators and numerators, and also, understanding that you can't just use rules and procedures to go ahead and do this. This is really a measure of fraction sense, okay? The third one has to do with domain 3 has to do with manipulates equivalent change to a fraction. So this deals with understanding equivalent fractions, right? Simplest form, being able to convert mixed numbers to improper fractions, because all of those skills, all those are really doing is you're just finding equivalencies or changing the structure of the fraction. And the last one has to do with arithmetic of fractions, okay? And it says procedures for addition, subtraction, and estimation, and understanding multiplication and division. So these domains are really well-rounded. It covers a huge range of skills from third grade all the way up to sixth grade. And this is going to give you a great profile of what your students can do, what they can't do, what are they struggling with, and more importantly, it's going to give you the data that you need to understand where you're going to start your instruction. So before we get into the actual assessment itself, I just want to show you some things that can help you too. So you're going to notice as you go through these questions, some questions, like if you see where it says skill 1, skill 1.1, skill 2, skill 3, see how those are colored in white or there's a white background? Any skill that has a white background, what that means is that that question is a question of fraction sense, which means there's not going to be a procedure, there's not going to be a process. It's either going to, measure really their sort of their raw knowledge of fractions. Do they understand this or do they not? There's not going to be a way where they can just memorize a procedure and get through that. So about 60% of this assessment has to do with fraction sense, okay? The next part is if there is a skill that is just colored in black, what that means is that's just a raw procedure. It'll say like for addition subtraction, it's not even a story problem format. It just gives them two fractions, says add them, right? Add and subtract with unlike denominators, add and subtract mixed numbers, add and subtract mixed numbers with unlike denominators. So it just gives them just the straight question and says, can you do this procedure or not? The next part of the assessment are called open concepts, and open concepts are in the gray part. And what this means is these problems can be solved in different ways. It can be solved through conceptual understanding or through application of a procedure. But it's not going to just have a procedure there and say, solve this. They're going to have to sort of look at the situation and apply the procedure, or they're going to have to look at the situation and apply their conceptual understanding. So what we're looking for is we're hoping that they are applying procedures, but we're also looking to see, do they understand conceptually this part of the assessment as well? And then a lot of people like to know, like, okay, if you were going to assign a grade level to these domains, the first domain is mostly third grade, just a little bit of fourth grade. But if we're going to kind of summarize it, it's third grade standards. Okay. If you look at domain 2, it's about evenly divided into third grade and fourth grade standards. Okay. If you take a look at domain 3, manipulates equivalent change, that is fourth grade standards. And if you take a look at arithmetic with fractions, a little bit of fourth grade, mostly fifth, and a touch of sixth grade as well. So don't look at this and say, okay, if I have fifth graders, I'm only going to give domain 4, because what you're going to realize is students who struggle, you're going to have fifth graders who can't get out of domain 1. And you're going to have sixth graders who cannot get out of domain 2. So it's important that you give the entire assessment, because the idea is not just to find out like the skills that they're supposed to know where they're struggling overall, so we can kind of go in and fill in those holes. So then when you do get to these procedures, that they have some understanding of what they're doing. So now what we're going to do is we're going to get into the assessment. The one thing is, if you want to have the assessment printed up ahead of time before we get into this, you can go ahead and go to the website. If you just go to Fractions Program and you scroll all the way to the bottom of the page, you can go to the Fractional Reasoning Assessment there. You can print it up, and then you can go along and print it up and score this along with us. The assessment pops up on the screen, so you don't necessarily need to do this, but some people like to have it to write notes on and things. So if you want to, go ahead and pause this, and then you can go to the website and print that up. So before we get started, one thing is this was filmed during COVID. So in a lot of the scenes we're about to see, students are wearing masks. So if you have trouble hearing the students, if you just get a set of headphones or a separate set of speakers and hook it up to your computer, you won't have any problems. Also, the day that this happened, the camera that we use, the battery died, so we had to use an iPhone. So it also doesn't have the best sound just because it's an iPhone. But most computers is going to be fine, and even most people will be fine. But if you're hard of hearing, or you have a separate set of headphones that you want to put on, it'll just help so you can hear things more clearly.
Also, too, at the very beginning, you're going to hear there happened to be a dance party on the other side of the wall where we were filming at. So you're going to hear you're going to feel like you're hearing music in the background. It's very slight, but it's not your background, it's the background from this too. So I just wanted to notify you that as well. So before we get started though, what I want to do is I want to go over how the assessment is set up, okay? So when you go to the first page, the fractional reasoning assessment, it's going to have, the student's name, the date, grade, and so on. And then it's broken down into domains. In each of the domains, it just has a quick summary of what the skill is. You don't use this for scoring. It's just to help you with your organization and kind of when you're done to looking how to use the materials, okay? The second page has the fourth domain on it. And then it also has the progress monitoring on it. And so you would go ahead and you'd write the date there, and then you would put a student's score in, and this can be used as your progress monitoring. There's only three boxes for 3 separate times. So if you need to do more progress monitoring, just run a separate sheet, and then you would go ahead and just put the new dates on it, and you can continually use this as a progress monitoring tool. Okay, so now what we're gonna do is we're gonna get into the actual assessment, okay? And the very first part is called Skill 1, and Skill 1 has to do with their ability to recognize a fraction as part of a whole or an area model and as part of a set. And for this first part, we're going to watch 2 students. And it's 2 students who are not only are students in the same school, but they're in the same grade and they have the exact same teacher. And I want you to pay attention to the differences. This assessment is going to pick up very quickly differences between these 2 students. We're going to have very different results from student 1 to student 2 based on just this initial part. And domain 1's often overlooked by teachers because they look at it and they say, my students will really fly through this. And so it's really good at picking up students who struggle as well. So we'll go ahead and we'll get started.
Okay, name each fraction.
1/2. 5/4. 4/5.
So he self-corrected unprompted, so that's fine.
That's good.
1/4. 2/6. 2/3.
Okay, what fraction?
So skill 1.1 is an extension of skill 1, but it's saying, can they take their knowledge of parts of a whole and parts of a set and transfer that to fractions on a number line?
Is the hard place at?
Three holes?
It's at 3 holes?
No. Three-fourths.
So he looked at it. The follow-up was just 3 holes, as in like that's the answer you're going with. Then he went through and recorrected. Again, he wasn't prompt. He wasn't led to think it was right or wrong. And he went back and he corrected it.
3/4, okay. All right, if you were to draw a dot, and I want you to draw a dot where you think 4/5 would go on that number line. So draw a dot with your finger where you think 4/5 would go.
So half would be here.
Go ahead and like make a big, you gotta like move it around. Okay. Go ahead and sit. So right about there you think is where 4/5 would go. Good.
Okay, now we're going to take a look at another student. Again, same grade, same teacher, same school, same math program. And this is, remember, this is the most basic parts of fractions too. And I don't know if I told you guys this, these are end of the year 4th graders. So there's only a few weeks of school left. They've already received their instruction for fractions for the year. So I would argue that end of the year 4th graders are probably stronger than beginning of the year 5th graders because there's the summer fallback. And so the skills are more fresh now. So again, these are, we could say they're 4th graders, but they're end of year 4th graders about to be 5th graders.
1 out of 2.
Okay, so how would you say that? What fraction is that?
4 out of 6.
So she's saying 1 out of 2, 4 out of 5. You see, we're marking it wrong because this is a test to see, can they properly identify a fraction using the correct terminology, the correct fraction language. And we'll see how important the fractional language is going out and making sure it's developed. So what she's saying is she's saying 1 out of 2. She's saying 4 out of 5. And they say, well, conceptually, she's right. But here's the problem with when they refer to fractions of 1 out of 2 or 4 out of 5. It could imply that they think it's 1 out of 2, like 1 out of 2 wholes or 4 out of 5 wholes. So think about when they get to mixed numbers or improper fractions, right? So like 6/5. How do you have 6 out of 5, right? That does not make sense to them. And also, if you think about when you're comparing fractions, right? Think of 1 out of 2 as half, and 3 out of 10 is 3/10. So even though we know half is more than 3/10, when you say 1 out of 2 or 3 out of 10, well, 3 out of 10 could be implied to be more than 1 out of 2 because 3 is more than 1. So when you're teaching kids about fractions, sometimes we fall into these shortcuts of saying, well, it's just 1 out of 2. And we don't think about some of the shortcuts, but these are shortcuts that, one, conceptually can create misconceptions for them. And two, when you try to grow fractions to other concepts within fractions, it almost can hinder them. Okay.
6/2.
Okay. What fraction is that?
1 out of 3.
1 out of 3. Okay. And what fraction would that be?
2 out of 6.
Okay. And what fraction would that be?
2 out of 3.
All right. What fraction is the heart place stat? So what fraction on that number line is the heart place stat?
3.
3. Okay. Okay. So if you take sorry, I was behind on this. If you take a look within the first question, right, first 2 questions, we have dramatically different results from 2 students who, again, are in the same class, same curriculum, same everything. And remember, they're done with their fraction instruction. So think when they start off in 5th grade is not the fundamentals or the basics. It's, adding fractions without common, or adding fractions and finding common denominators, and multiplying fractions and dividing fractions. And so think about how one of these students who doesn't even have the basics, when she goes into 5th grade, she's going to be doing all these concepts that are already way ahead of where she's at because she just does not have a good foundation for fractions. The next skill that we're going to look at is skill two. And this has to do with counting by fractional parts starting at 0 and going up to 1, or building one whole through fractional language. Can you count by 8s starting at 0 and stop at 1? So count by 8s starting at 0 and then stop when you get to 1.
8. 6. Wait.
No, not count by 8s, count by 8s. 8s.
Like, count. I'm confused.
Okay, so if you're going to count by... So this is hard for a lot of kids because they're not used to being asked how to do this. So there's a difference between trying to explain this to them and actually prompting them. You don't want to prompt them. You just want to keep asking them, count by 8s, count by 8s. If they can't do it, it's not a big deal. It's something you'll deal with in instruction, and most kids pick up on this really quickly. Counting by fractional parts, right? So can you count by 8s, like 8s starting at 0?
Oh, 1 8. Like 1 8, 2 8, 3 8s, 4 8s, 5 8s, 6 8s, 7 8s, 8 8s.
Good. And can you count backwards from 6 starting at 1 or 6 6?
6 6, 5 6, 4 6, 3 6, 2 6, and 1 6.
Good. Okay, I'm going to ask you now to count by fractional parts. So count by 8s starting at 0 and stop at 1.
0 8s, 1 8s. Wait.
This is a really common answer, even from students who tend to be really strong at fractions or have a good concept. They're just not used to doing this. So you're going to start at 0, and you're going to count by 8s up to 1.
Oh, 1 8.
Is that it?
Yeah.
Okay. Okay, the next skill we're going to go to is skill 3, and this is name as a mixed number or an improper fraction. They can name it as either, and the goal of this is to see, can they recognize or name a fraction or mixed number that's greater than 1? 99% of kids who answer this question correctly will answer it as a mixed number.
Name as a mixed number or an improper fraction. What fraction is that?
One and 2/5.
Good. Again, name as an improper fraction or a mixed number.
2 and 1/4.
Okay, draw a dot where 5/3 or 1 2/3 would go on this number line. So either 5/3 or 1 2/3. Where would it go?
So 5/3 or 1 2/3.
Mm-hmm.
1 2/3.
Good job. Okay, which?
The next skill now, this is still domain 1, but it's called understanding one whole fractions as part of a whole. So skill 4, 5, and 6 all have to do with going very deep and making sure they understand what the concept of a fraction is and understanding within the context of one whole. So skill 4 has to do with, do they understand that a whole that is in fraction form is still more than a regular fraction? And then take a look at the first visual, okay? And remember, for these, what you're looking for, because kids are really bad at explaining their thinking. So you're looking for keywords such as one whole, more total amount, not a whole, all the parts were not there, all the parts were there, okay? And when you go through this part too, what you want to look at is, we're looking for, do they have evidence of understanding? Do they have evidence of a misconception? Or are they unable to explain? So once they give us evidence of understanding, and we believe that they've shown they understand that concept in that way, you go ahead and mark evidence of understanding and move on. All right, if it's evidence of misconception, unable to explain, obviously that means they did not get it correct, and they would not be able to get this section. So you have to get all the answers correct in this section to be considered, to have that skill mastered, okay? So let's take a look.
Which fraction is greater? Which is greater?
Oh, 4/4.
So he says 4/4, right? So remember, they have a 50% chance of getting this right just by kind of guessing. So the explanation is the most important part.
Why is 4/4 greater?
Because the less pieces you have, say that's a pizza, the less pieces you have, the bigger it would be.
So he's saying the less pieces you have, which is fourths, he's saying, and all the fourths are there. So the less pieces you have, the more you have, and all of them are shaded in. So therefore, right, remember, it's greater. So he's given enough to explain.
The bigger the pieces would be.
Okay, so you're saying this one's definitely more than that one, though. Okay. Which is more?
Now take a look at this one. It's just giving them a traditional compare this 1 whole to 3/4.
3/4 or 1?
1.
And how do you know that?
1 is 1 whole.
He said enough. 1 is 1 whole. That's all we needed to hear.
And 3 and 4 is not 1 whole.
Okay.
Take a look at this one. 1 whole in a different structure now. 3/3 is the same as 1 whole. And also, take a look. This is set up where 4 and 5 are both larger than the 3s, right? To see if they will, use inappropriate use of whole number reasoning. So this is why the design of that question was designed to do.
Which is more, 3/3 or 4/5?
3/3 because it's 1 whole.
Again, 1 whole. That's what we're looking for.
And because, like, if it was, say it's a pizza, you'll have 3. The 4/5, wait. 4/5, you have more pieces, but they would be smaller.
Okay, so you're saying 3/3, so which is greater then?
3/3 because it would have less pieces, but bigger pieces.
Okay.
And that would equal like 2 of that.
Okay.
Again, it's very hard for kids to verbalize this. He acknowledged that 3/3 was a whole and that 4/5 was not. And that's what you're really looking for.
All right. How much more would I need?
Skill 5 has to do with completing one whole. So when given the fractional part, do they understand how much more you need to make it one whole?
To have one whole.
2/5.
How much more would I need to have one whole?
2/3.
And how much more would I need to have one whole?
3/7.
Okay, now skill 6, there's 2 parts to skill 6, and it has to do with comparing a mixed number to one whole in different forms, and then comparing an improper fraction to one whole in different forms. So again, this is one where you're looking for keywords such as, more than one whole, or you have 2 wholes. And so again, you don't want to get into dissecting every word they say because sometimes they'll just kind of stumble through, but you're really looking for those keywords, okay?
Okay, which is greater, 1 or 2 1/4?
2 1/4 because 2 is 2 holes, and if you
That's all we're looking for. Yep, the 2 holes is definitely more than one whole.
have just one, 2 is larger than 1.
Okay, so 2 is larger than 1, so the fraction doesn't even matter. Good. Okay, which is more, 3/3 or 1 1/2?
1 1/2 because 3/3 it is just one hole,
Again, acknowledgement, 3/3 is one whole.
and this and 1 1/2 is a one hole and then a half.
Okay. Okay, which is more, 5/4 or 1?
More?
Which is greater?
Well, 5/4 because 5/4 is 1 and 1/4.
Okay, so you're saying 5.
All right, when they're converting, impropers to mixed, they understand.
4 is a whole, and then a little more, and 1 is just 1.
Yeah, as a mixed number.
And again, this last one, again, it's set up where it's seeing do they understand one whole, or will they go to inappropriate use of whole number reasoning? Because obviously, to the untrained eye, 9/9 looks like it's more than 7/4, but it's really digging deep to see if they understand that.
Okay. Which is greater, 7/4 or 9/9?
7/4 because it's 1 and 3/4.
Very good.
Again, good explanation. Also, as you give this first section to, 4th, 5th, 6th graders, you're going to be surprised how many students struggle with these most basic concepts. And if a student can't get through domain 1, they're going to have a really hard time in 2, 3, and 4.
Which would be more, 3/3 or 4/5?
3/3
And how do you know that?
because 3 is
So she has it right, but remember, they have a 50% chance of getting it right. So her explanation for why it's greater matters.
greater than 4, and then 5 is way too much, so that's why.
She said 3 is greater than 4 and 5 is way too much.
Okay.
So obviously that's not a satisfactory, and that's evidence of misconception or unable to explain, because it's both.
You're saying 3 is greater than 4 and 5 is less?
Mm-hmm.
So you're saying 3/3 is greater than 4/5? Okay. Which is more, 1 or 2 1/4?
1.
And which is more, 3/3 or 1 1/2?
3/3
And how do you know that?
because there's one more, and that would be too much.
So you're saying that 3/3 is more than the 1 1/2? Okay. Okay, which would be more, 5/4 or 1?
1.
And then why do you say that?
Because there's like a 4 and there's like one number, 4 number, like.
So you'll notice kids who really struggle when they're explaining, they don't understand. So just accept what they're saying. Don't try to get anything more out of them because they're just talking because they know they're supposed to be talking to you. So sometimes, our job isn't to try to correct them, just let them talk and then move on.
1.
Okay. All right. Okay, compare these two fractions. So we're now in the second domain, and the second domain has to do with comparing fractions with defined characteristics. Okay, so when going through this, each one of these skills is comparing a different type of fraction with a defined characteristic. But the first thing is the evidence of understanding. This one says use of procedure, evidence of misconception. Especially if you are giving this to older students who have been proceduralized and they know that they can just cross multiply, it's fine if they do that. However, they still have to give an explanation, and it can't have to do with anything with the procedure. Okay, you can't say, well, 8 times 2 is 16, or 8 times 2 is 16, and 8 times 6 is 48. They have to explain the reasoning for it. Okay. Tell me which one's greater. I'm sorry. In skill 7, it has to do with comparing fractions with the same denominator or like denominators.
I think it. 3/4.
Okay.
Because they're both fourths and the same amount of pieces and same size, and there's just 3 pieces, and that one there's 2.
Perfect explanation. They're both in fourths, and one has 3 pieces and one has 2. All right. Now the next problem is the same concept, but in an abstract form, right? It gives it to them concrete. Can they do it in the concrete? Can they transfer it to the abstract? Good. Okay, which is greater or which is more, 2/8 or 6/8?
Well, 2/8 is greater because it's because 2. Oh, 6/8 because 6 is larger than 2.
So he goes from 2/8, then he goes to 6/8.
No, 2/8 because 6. If you had 6 pieces of pizza out of 8, you would have smaller pieces than 2/8.
Okay, so you're saying 2/8 is greater than 6/8. Okay. Okay, so the real what he just did is something called numerator denominator confusion. He treats the numerator as if it's a denominator. And what that means is if you take a look right here, he starts talking about pieces, right? And so he's not viewing the numerator as an accumulation of the pieces in the denominator form. He's viewing this in 6 and this in halves, right? And we know that halves are bigger than 6. So because he knows halves are bigger than 6, he's going with, that's why 2/8 is bigger. So he has numerator denominator confusion, total normal thing. A lot of kids do that. And if you take a look, he did not transfer the knowledge from the visuals to the abstract. Okay, which is greater? The next one, skill 8, and what skill 8 has to do with is comparing fractions with the same numerator. So it'll have them compare a picture. They'll have them compare 2 unit fractions and 2 regular fractions with the same numerator. Okay.
One-fifth because it is.
So he says 1/5. He's about to give an explanation for why. It probably has something to do with fifths. It has more pieces.
There's. Oh no, 1/3.
Then he looks and he now sees the visual. So he's now going to go ahead and explain what he visually sees.
See that piece? If that was another green right there, that would equal just one of those pieces.
So he's now saying, essentially, look at this piece, look at this piece. This piece is bigger than that piece, so I know I have more. Okay. So in your notes, you'd want to say, really be, dependent on the visual to get that one right.
Okay, so you're telling me which one is greater than the other one then?
Oh, this one, because it has larger pieces.
1/3 because the pieces are larger. Okay. Okay. Which is greater, 1/4 or 1/8?
My mom said, she told me that it depends on like.
Whenever an explanation begins with "my mom told me," it usually doesn't really end up going well.
Oh no, because this isn't the same thing. 1/8, because like 8 is, you could get more pieces than 4.
Okay, so you're saying that 8 is more than 4, so 1/8 is more than 1/4 because there's more pieces in 8?
Mm-hmm.
Okay. Okay, which is greater, 3/7 or 3/9?
3/7, because if you have 3 pieces, so if you have 3/7, then the pieces would be larger than having 3/9, because they would have, if you had a circle, the 3/9 would be kind of like cramped in.
Okay.
And for 3/7 it wouldn't be, because you would have less pieces.
Okay.
Okay, so something that's really interesting is, right, kids who are confused by fractions and have misconceptions, he's correct in his explanation. Like, for whatever reason, when he saw that fraction, he's able to identify the characteristics and do it. Now, when it was 1/4 and 1/8, he was not able to. So in our notes, 1, he needed the visual, okay? He got 2 out of 3 right, but remember that first one, he was about to explain to us why 1/5 was larger than 1/3 until he visually saw it didn't match up. And the other thing is what he's doing when with the unit fractions, he's using whole number reasoning. He's saying, okay, an 1/8 has more pieces than a 1/4, which is true, right? An 1/8, it does have more pieces than 8s do have more pieces. The problem is he's not paying attention to the numerator. He's just looking at the number and saying, oh, 8 is bigger than 4. So he's applying whole number reasoning. You can't apply whole number reasoning to fractions because it's an inverse relationship, right? The larger the pieces, the smaller the pieces as well. So again, with the first 2 skills in domain 2, we picked up on some pretty big misconceptions that he has that is going to help us when we choose our instruction for this student. Okay, the next skill has to do with both fractions are one piece away from one whole. So can they use that piece that's away to figure out which fraction is greater?
So 3/7 is greater than 3/9? Okay. Okay, which fraction is greater here?
2/3, because it has big.
So even though it's visually obvious, he is so fixated in the size of the pieces, but not the accumulation of pieces. Okay, that's a sort of a theme with him. He's very, he understands that 1/3s are bigger than 8s, right? When he can see it. So he's fixated on, well, because those pieces are bigger, it has to be more, right?
It has larger pieces.
Okay. So you're saying 2/3 is definitely greater than this one because it has larger pieces?
Mm-hmm.
Okay.
Okay, same concept now. And then when you do this one, it has a prompt for question 2. It says, both fractions are one piece away from one whole. Use that piece to explain which is greater. So remember, what you're looking for is with 5, 6, right? So 6, we know that 6 are smaller than 4ths, right? But we're one piece away from a whole. So what we have is we need 1/6 to get to a whole. For 3/4, we need a 4th. So actually, though a 4th is larger than a 6th, you need less at 5, 6 than you do for 3/4. So actually less is more. So they're seeing is, can they apply that skill?
Both fractions are one piece away from being a whole. How can you use that piece to explain which one's greater? So which is greater, 5, 6, or 3/4?
I'm gonna go with.
So each one's one piece away. So how can you use that piece to tell you which one's greater?
3/4, because 3 it would be larger than 5, because like it could be a triangle pizza. It would have three triangles out of 4. So you ate one, but you have 3 left. And you ate one out of the 5, 6, and you would have 5 left. Then the pieces would be smaller because there would be like more that you would need in all. So 3/4 is bigger because it would have larger pieces.
Okay.
Again, he has a denominator focused strategy. There's no connections to the numerator. He doesn't understand. And so again, this is an area we know we can target in on instruction is characteristics of fractions. He's not really understanding how to compare them. Okay. And the last one has to do with question 1 and 2 has to do with using the benchmark of half to explain. So it's going to say for question 1 and question 2, use the benchmark of half to explain to me which fraction is greater. Can they do it with visuals? Can they do it with 2 fractions that are in the abstract form?
Just less, but larger because like it would have less pieces, but they would be larger.
Okay.
So
you're saying overall 3/4 would be more than 5, 6 because the pieces are.
And it may seem confusing, like what does he need? Once you do the activities, then the activities are designed to sort of clean all this up in a way. So you don't have to be an actual expert at diagnosing every little misconception because what the instructional activities do is it will clean up all of this for you.
Bigger in 3/4 than they are in 5, 6. Gotcha. Okay. So use the benchmark of half to explain which fraction is greater. So can you use the benchmark of half to explain which one's greater?
Well, yeah, because this one it has like 2 at the top and then 1 at the bottom, and this one has 3 at the bottom and 1 at the top. That one would be larger.
Okay, so this one. But can you explain how?
So he kind of told us, but you want to question again because he said nothing about half yet.
Oh, you could use half to figure this out?
Because you could see the dark half line, and then you have 1 at the top.
Okay. They're saying there's the half line, there's 1 over the half, right?
Okay, so you're saying there's the half line and then there's a piece on top of it. Okay, makes sense. Okay. So 6/10 or 4/9, which one is greater? And can you use half to explain which one is greater?
So 4. Six isn't half of 10 and 4 isn't half of 9, so I have to go less. So 3, 6, 9.
So he basically said both of those are less than half, which is not true. So it's already an evidence of a misconception, regardless of what answer he gives.
So that's 3, and then 2 if that's a 5. So 4/9 would be bigger.
4/9 is greater using the half benchmark. Okay. Which is greater?
Okay, we're now going to view another student who tested really well at domain 2, who has really strong fraction sense. And this is almost, I don't think I could explain these answers better than she did. So it's really good to see a child, or a student using these types of strategies and the explanations we're looking for as well.
3/4.
Okay. Which is greater?
6/8.
And how do you know that?
Because 2/8 is 1/4, and then 6/8 is 3/4.
Oh, wow. Which is greater?
1/3.
Okay. Which is greater?
1/4.
And how do you know that?
Because 2/8 is 1/4, and that's 1/8.
Okay. Which fraction is greater?
3/7.
And how do you know that?
Because 7th pieces are bigger than 9ths.
Very good. Okay, which fraction is greater?
7/8.
Okay, both fractions are one piece away from being a whole. Can you use that piece to explain which is greater, 5, 6, or 3/4?
5/6 is greater because 6 are smaller pieces, and 3/4 would be farther away from 1 whole than 5/6.
Again, I could not explain this better than this child has. Which is greater?
4/6.
Okay. So I want you to compare these two fractions, but I want you to use the benchmark of half to explain which one is greater.
Okay. 4.5 would be half of 9.
I wouldn't even have said that. I just would have said 4/9 is less than half and 6/10 is greater than half.
And that's 4, so that is under a half. And 5/10 is under, 6/10 is, 5/10 is a half, and 6/10 is over half.
That was really excellent. Okay, and sorry for the last part for skill 10, he needs the visual. He's unable to see half as part of fraction. So if you think about the student too, his name's TJ. He went through the first six skills almost like flawlessly. Went through everything, looked fine, and then domain 2 is it's a more difficult domain, right? And it's how well do you really understand fractions within the context of not just fraction as part of a whole, but now fractions in comparison to each other. And so it's a more difficult skill. And so what's good is the assessment's doing exactly what it's designed to do. We have tons now of skills that we know he needs to work on. We have the resources we know that we can use to help fill in these holes too. And we have a lot of teaching points. And what's good about TJ is he's just your typical, he's your typical student. He exists in every classroom, right? No matter where you teach, you're going to have a student like him who has some fraction knowledge, right? And then he has some misconceptions. And then the first student we saw too, Hannah, you're going to have students like her who have really struggled with fractions and really need a lot of more support too. So it's good just to see different kinds of kids take this assessment and see the results you get from it. Okay, the next part, what the next part has to do with is it has to do with, this is a tougher domain now. And this has to do with manipulates change to a fraction, equivalent fractions and common denominators.
What are all the fractions that are equivalent to k, to point k? So which fractions are all equivalent to point k?
So 1/4. So 1/4 could be there, then half, then 3/4, then 1 whole.
Okay, so do you see point k right here? I want to know which.
Though he's kind of talking about it, he didn't really explain the answer to the question.
Fractions are equivalent to point k, or the same.
Oh. 2/4 because, so if it was 8.
So he's correct. He kind of says 2/4.
It would be 2/8 because,
and then he's not correct.
It would be 4/8 if it was 8 because 4 is half of 8.
Okay.
And 4.
So what you're looking for is when you say what are the fractions equivalent to k, you're really looking for them to say 2/4 and 4/8. Like that's really all you're looking for them to do. Can they make the connection between those number lines?
3s would be 3/6 and 6.
So he's now naming equivalents for half, even ones that aren't on the number line, but we want him to actually just say 2/4 and 4/8.
If it was 6, it would be 6/12.
Okay. So for point k, do you see where the k is?
Mm-hmm.
So can you tell me what fractions are equivalent to that point k then? If you don't understand, it's okay to say you don't understand too. So
I don't really understand.
okay, that's fine.
So what seemed to be happening, and you obviously can't teach, he's not viewing the number lines in connection with each other. He's viewing them as he's not viewing them as lining up with each other. So he's viewing it as like an independent thing where he's not realizing that. So, but again, without teaching him how to use that, he's not going to be able to do that. So it's fine. He just doesn't understand it. This is not a skill that's really hard to teach, but it's something he's going to have to go over. Okay. Now, skill 13 has to do with now it's funny because 12 kind of helps us predict it. He was really good at telling us equivalents for half. So now it's, can he find equivalent fractions for half with automaticity, which means without, calculating? Can he just do it by understanding, a number is half of another number?
That's fine. So remember, some of these things you'll know, some you won't. Okay. Which fractions below are equivalent or the same as 1/2?
2/4.
Okay.
4/8. 3/6.
Okay, perfect.
Is that it?
I'm gonna go from the beginning now. So 2/4 so far. 4/8. 3/6, and that's all.
Good.
Because 3 is half of 6, 2 is
Okay.
half of 4.
Okay, the next one has to do with writing an equivalent fraction for one fraction, and then writing equivalent fraction in simplest form for the other fraction. Okay, so that's what skill 14 is. It is essentially equivalency through multiplying and then finding equivalency through dividing in simplest form.
Okay. Can you write an equivalent fraction for 3/5?
What would make 3/5?
So can you make an equivalent fraction for 3/5? So another fraction that means is the same as 3/5.
Oh.
Okay. All right. So what you did, you definitely broke 3/5
So he decomposed it down, which is a good skill to have, but unfortunately it's not finding an equivalent fraction.
down into fifths. Okay. So, okay. Can you write an equivalent fraction for 5/15 that's in simplest form?
Like 3/5.
3/5. Okay.
Okay, so what happens now is he gets skill 14 wrong. We go to skill 15 and I ask him, can he find an equivalent fraction? He talks for a few minutes about how he knows how to find an equivalent fraction and that they've worked on them. He remembers it and he goes on and on. He's trying to explain it, but he never actually goes up to the board and tries and never actually really attempts it. So now what we're going to do is we're going to go to another student who actually attempted and did not get this problem correct, just so you can see what it looks like, because he didn't attempt the problem. And if they don't know how to do it, there's no point in forcing them and making them go up. Obviously, you don't want to accept all the time, like, I can't do it. But if they legitimately don't know how to do it, there's no need to put them through the stress of trying to do this when the assessment's to find out what they can and can't do. Okay. So it's going to go to another student who did this part. And also after this part, if you take a look where it says administer admissible procedures worksheet. So when you're giving the student one, it's going to tell you when to administer a different part of it. That's a paper pencil part that you don't do as like an interviewer type question. So just so you know that.
Okay. Find a common denominator for the set right there. Find a common denominator for that set. So that's the common denominator for those two? Okay. And find a common denominator for that set. For 1/2 and 3/5. Find a common denominator.
Okay. Okay, so now we're going to come back to this assessment part too. Sorry, I was late on scoring this. So for 3/5 and 5/15, he was not able to do that. And that has to do with the equivalent fraction. If you remember to skill 14, we talked about open concepts. That's one where the procedure is not there for them. They have to apply a procedure. So even though it's, multiplying or dividing by a number, again, they have to administer that procedure. It's not set up where it says, 3/5 times 2 halves in that way. And then same thing, finding common denominator, that requires a procedure to do that. They have to apply the procedure. Okay. So up to this point now, when you give skill 1 through 15, it's all done as an interviewer type question. Okay. Now the next part, so when you get to skill 16, 17, and I'm going to show you this, where it says skill 16 and 17 and 18, 19, 20, 21, this is a separate worksheet where this is a measurement of procedures, okay? So you don't administer this part like where you're asking them the questions. You just give them the worksheet and you have them go through and solve the problems, okay? So here's how this is not really confusing, but 16 through 21 is done in a worksheet where you don't do anything, you just give it to them. Now you can give them this before you do the interviewer part of the assessment, or even after, or you can do it the day before. Because when you give the assessment, you give skill 1 through 15, and 16 through 17, 16 through 21 is given through a worksheet, okay? Then the next part, skill 22, that is still an interviewer question that has to do with adding numbers and estimating. So you're going to go from 15 to 22. You'll skip these because it's on the worksheet. And then this next part, it says domain 4 arithmetic strategies. Again, this is another worksheet, okay? So what you basically technically can do is, because you can run in the materials, these are one after the other, you can run these front to back and you can give 16, 17, 18, 19, 20, 21, 23, 24, 25, 26. These are all done with just the student on a worksheet. You're not doing any type of asking of any questions. You're just scoring it, okay? And then the very last part is 27. So you give skill 1 through 15, you distribute these worksheets, and then you go ahead and do skill 22 and 27. And again, you can give these worksheets before the assessment, the day before, after. If you want to go in order where you go 15, then give the worksheet, give them time to work on it, then administer question 22, and then give them the other worksheet, and then go there, that's fine. But it just makes sense to give this as one ahead of time, and then you don't have to worry about it, okay? It'll help save you time too. All right, so we're going to take a look now how he did on the procedures part, okay? So if you take a look at the first part right here, and what this says is it says convert to an equivalent improper fraction, right? So this is a mixed number. So what he did is he showed really good conceptual understanding, okay? He drew it out, and the answer is 11/5, and he drew out 11/5. Even if he would have wrote 11/5, it's not what we're looking for. What we're really looking for is applying that procedure. And though this is great, right? It's awesome that he has this conceptual knowledge. The problem is, in a short time, he's going to be dealing with 13 and 9/15, right? If he's going to draw out 13 and 9/15, that's going to take him about 4 pieces of paper in an hour to do that. So we're seeing now, okay, it's great. He understands conceptually how to do it, but now we're really seeing, are they applying those procedures? Because as we know, the curriculum takes off quick. And if he doesn't have those procedures down and connecting them with those concepts that he does understand, so the instructional part is going to be easy because it's just going to be focusing on the procedure for him because he knows how to do it. And the same thing for 7/4, right? Is he able to connect that into dividing? And again, 7/4 is something really easy to do, but say it was 36, 36/5, right? And he's trying to draw that out. Again, time consuming, inefficient strategies. So again, awesome that he understands it. And that's great. But what we're looking for is application procedure, because they can't just get through fractions, just conceptually understanding everything. They also have to tie it in with procedures, which is kind of opposite of the first part of this assessment, which is focused completely on fraction sense and concepts. Now it's like, okay, you have to also have these procedures in place. All right, skill 18 and 19 has to do with adding and subtracting fractions with the same denominator. He was able to do that. Skill 19 has to do with adding and subtracting fractions. With unlike denominators, he was not able to do that. Skill 20 and 21 is adding mixed numbers with the same denominator. He was able to do that. He understood how to group the wholes and then add the fractions. In skill 21 and 22, not only is it adding and subtracting mixed numbers with unlike denominators, it also involves when you're adding, you're creating a new whole. Do they know how to group and make that new whole? Subtracting, they have to ungroup a whole to help them subtract. So that's what that measures there, okay? Now, if we take a look at his multiplication division part, right? Now, again, these are open because it's not presenting them the question that looks like this. It's not saying 1/4 times 24. If we just gave them that, a lot of kids would be able to get that right without having any type of understanding of it, because procedurally, multiplying, dividing fractions, procedurally is very easy. Conceptually understanding, it's hard. So it's just giving them a really short, word problem. Can they pull out of this what they need to do? Okay. So he didn't really show any work, but he said 1/4 of 24 is 5. Okay. For the next one, what is 2/3 of 3/4? And he put 1/1. So not really sure what his thinking was, but we know that he's just not ready for this. Now for skill 25 and 26, this is even a deeper look at it, because when you multiply fractions, though the context matters, it doesn't matter what order you put them in, you're going to get the same answer. The context can change depending on what you're doing, but you're going to get the same answer. Whether you view this as 1/3 divided by 4 or 4 divided by 1/3, you're going to get different answers. And this one says how many 1/3 will go in the 4. So you're dividing 4. So the answer would be 12. If they put numbers in the wrong order, there's a big difference between having 12 and 1/12. Again, the same thing, how many 1/8 will go into 3/4 means 3/4 divided by 1/8, which equals 6. If they divide it the wrong way, if they even know to divide it, that too. So this is a really good measure of just quick. And again, it's not these complex story problems. It's can they identify the function of what we're asking them to do, and then can they do the procedure or not? And again, like for this one, sometimes you may have kids who try to solve it through conceptual understanding. If they can do it conceptually, that's great. But it gets to a time where you have to start to tie in procedures with the conceptual understanding. Okay. So now we're going to go through and we're going to finish up the rest of the assessment. We're going to see what skill 22 looks like. And this has to do with adding fractions. And then we'll go back to, I'll just stay on this sheet right here. So where we're at right here, and it's already scored, we're at estimate where 1/8 plus 1/10 would go on this number line.
Where would the answer to 1/8 plus 1/10 go on the number line? About where would the answer go? So if you're going to draw that, and I don't want you to solve the problem, I just want you to just draw.
And think 1/8 and 1/10, it's going to be, really close to 0 or somewhere in between, 1/2 and 0. That's what you're looking for. We want to see, okay, without solving this, about where would this go?
A dot where you think the answer of 1/8 plus 1/10 would go on this number line.
1/8 and 1/10.
Mm-hmm.
I'd say 1/10 right here.
Okay.
Because 10 would be a whole. It could be a whole. Well, I'm confused. Because 1/8 and 1/10.
So if we're going to add them and then we're going to put it on that number line, you think that's about where it'd go? At about 2?
If we added them?
Yeah. We're not actually adding them. I just want you to think about if we did add them, where would it go on this number line?
I don't know.
It's okay.
Okay. So if they get the first one wrong, it's fine. You don't need to give the second one because they have to get both of them right anyways. The next one has to do with estimating where a mixed number plus a fraction would go on that number line. So what's interesting about this last part too is the very last question is, if you multiplied 5 by 3/4, will the product be larger or smaller than 5? So, and they're not allowed to solve it. You just have to, they have to look at it. And obviously you want them to say, when you're multiplying a whole number by a fraction, you're only taking a fraction of it. He got kind of stumbled up on the question, and the kids knew that we told them that, we show teachers how to teach math, and we watch kids solve problems. And what we want to do is we help you teach teachers how to teach. And so for the very last one, he kind of got upset because he knew he was kind of stumbling through. And so he asked me if I would not show the last one. So I'm kind of honoring my word of not showing the last one, because he wasn't even able to. He just kind of talked about it for a little bit, but he did not actually explain it. So to honor my word of telling him I wouldn't show it, we're not going to show the last one, but we will watch a student who is able to kind of get through that part too. Okay. And skill 27 is the last one. So now we're going to kind of go back to the parts that he struggled with, watch another student go through those, and then we'll work our way up to the end of the assessment. So we're just back at skill 14, and we're going to watch her go all the way through up till 27.
Can you write an equivalent fraction for me? Can you write an equivalent fraction for me that puts this in simplest form? Okay. Good job. Okay, can you find a common denominator for those two numbers? Can you find a common denominator for those two numbers? So your common denominator is what number?
12.
Good. Can you find a common denominator for those two numbers? And what was your common denominator?
10.
Good job. Second. Okay. So about where would the answer to 1/8 plus 1/10 go on the number line? So I don't want you to solve it. I just want you to tell me, like, estimate about where you think this would go on the number line and draw a dot.
Okay. Maybe like somewhere over here.
Somewhere around there? Okay.
Okay, and you know what you're looking for is basically like within like a half of where it's at. So, you know, the real answer will be out there. So she's pretty close. So I'd go ahead and give her credit for that one. Now this one, think about it, 1 and 11/12 is essentially 2, 9/10 is essentially 1. You're looking for an answer that's around 3.
Now about where would the answer to 1 and 11/12 plus 9/10 go on this number line? About where do you think it would go?
Maybe around here.
About there. And why do you say that?
Because 1 is already over 1. Well, 1 and 11/12 is already over 1, and that's like right here, and a plus 9/10 would get you to about this area.
About right in there? Okay. All right, sounds good.
And again, as you're going through, it's going to tell you to administer that part. You would go through administer that part. We're not going to go through that with her. We'll go to the very last part.
Okay, so if you multiply 5 by 3/4, will the product be larger or smaller than 5?
So again, they can either say larger or smaller, but they have to explain their thinking.
I don't want you to solve it. I just want you to tell me if you think the answer would be bigger than 5 or less than 5.
I think it would be greater than 5.
And why would it be greater than 5?
Because 3/4 is over. Wait, no, I don't think that it would it wouldn't be greater than 5 because 3/4 is not even a whole, and then 1 times 5 would get you to 5.
So she's referencing multiplying by 1 will get you to 5. And now that she knows that 3/4 is not 1, it's like excellent thinking in the way she's reasoning through this.
And 3/4 is just a fraction of a whole, so it wouldn't get you over 5.
Okay. If you multiply 5 by 2.5, will the product be larger or smaller than 5?
It would be larger because 2 is already over a whole, and that would get you greater than 5.
Excellent job. Great job there. So, all right. Okay, and you may be wondering as we go to the next part, you may have already noticed this, or maybe you may not have noticed this, but you may be thinking, what happened to skill 11? Skill 11 was taken out because it was deemed to be not a relevant skill. So the program was pretty much made, and then decision was made to take skill 11 out. So that's why it goes from skill 10 to skill 12, in case you're wondering. Okay. So when giving this assessment, just remember a few things too. You need to keep in mind who you're giving this assessment to, what grade the student's in, and know your grade levels as well. So remember, the assessment is a snapshot in time of a student's skills. The assessment will develop a detailed profile of a student's skill set in 15-20 minutes. The data that comes from this is imperative. If you think about, if we didn't have the data from, say, TJ or Hannah, those students who we just had, we would almost be teaching blind. Yeah, we'd be working on fractions with them, but probably not what they need to work on with fractions. The second part is if a student struggles with domain 1 and domain 2, you can stop. You already have your instructional target skills. So if you want to, I like to give the entire assessment because I feel like then it just gives you your baseline. Then you can look at growth from all aspects of the program from, this is what they knew before, this is what they knew after. But if you're going through and a child's really struggling, there's no point in putting them through domain 3 and domain 4 when you know that they're not going to be able to do it because 1 and 2 are, a prerequisite for those two. Okay. And the third part is know your grade level. This is going to look very different for working with third graders, right? Third graders, you're going to be almost exclusively focusing on domain 1 and a little bit of domain 2, right? Fourth graders, you're going to obviously want to make sure they can get through domain 1, and fifth graders, and then focusing on 2 and 3 and 4. So just know your grade level and realize you're not going to have a third grader multiplying, dividing fractions. So make sure you understand that as well. Okay. So now we're going to look at how to tie together all of the instructional components of this. Okay. So this was TJ. We went through and we did all of his scoring of everything where he was at. Domain 1, no problems, 100%. We can clearly see his breakdown starts in domain 2 and it goes all the way for starting at skill 7. Okay. And then we know that there's other skills that we need to work on as well, but we're going to work on domain 2 first, skill 7, 8, 9, and 10, because that's exactly what he needs. Once we can get through those and he's satisfactory, then we can start to work on a lot of the other skills too, domain 3 and domain 4 and so on. All right. So remember, for him, if we were going to go through, skill 7 is the first skill that he needed help with, and they had to do with comparing fractions with the same denominator. We would go through and do the activities. And remember, there's a video you can watch, and we're not going to watch this one. And then next two students, we'll watch just the quick video just to see how it shows you how to do the lesson or the activity for that. And then there are the assignments that go along with it. Okay. Now take a look here. Remember Hannah, we know that she struggled immensely. Okay. If we didn't see it the whole assessment, but she basically is stuck in domain 1, domain 2. We didn't have to give her 3 or 4, but we knew what the results would be. But so we know exactly what she needs now. Okay. So again, if we were to go through and we're going to focus in on those early domains, skill 2, counting by fractional parts up to 1, we would go ahead and do these activities with her and give her the lessons. And so this is just, when you click on this is just a quick video of how to do skill 2, activity 2. And then there's obviously the practice component that goes with it.
Activity 2. Objective to learn how to count by fractional parts from 0 up to and past 1 whole. To build 1 whole with language and immediately recognize when the numerator and denominator are the same non-zero number, you have one whole, okay? So here's what we're gonna do. We're gonna, first of all, these are the models that we're going to be working with. And let's compare just so we can see the difference, because this is gonna be a more difficult activity than the last one. And here's why. The last activity that you did, it used bar models, okay? And think about it, on each one of these bars, it tells you, okay, that's a third. So whether we had 2 or 3 or 4 or 5, they immediately knew, okay, well, these are thirds, so 1/3, 2/3, 3/3. They didn't have to figure out, okay, what fraction is this piece? It told them that, and then all we did was count. So now we're going to a more abstract model, okay? So the first thing you want to do is to go ahead and have your students focus in right up here on this first one and say, all right, what I want you to do is color in one piece of every circle, okay? So they're going to go ahead and be careful not to give them the answer. Don't say, color in 1/2 of each one. Just say color in one piece of each circle, okay? So we're going to go ahead and we're going to color in one piece of each circle, all right? Now, when you say what fraction is shaded in, your kids who struggle, a lot of them are going to go like this. They're going to go 1, 2, 3, 4. So we have 4, right? And they're going to go 1, 2, 3, 4, 5, 6, 7, 8, and they're going to say this is 4/8, okay? Well, we know this isn't 4/8. What was their mistake? They're treating these, instead of each one of these as an individual whole, they're treating this as all of this as a whole. So you have to remind them, say, okay, we're right about one part. The 4 is correct, because remember, your numerator is your counting number. How many we have? 1, 2, 3, 4. We have to figure out what did we count. Now remember, if each one of these is a whole, right? And so if there's 1 out of 2 pieces, so this would be 1/2, and this would be 1/2, and this would be 1/2, and this would be 1/2. So what do we have? We have 4 halves. And again, we're not interested in saying this is an improper fraction this time, because we just counted, right? 1/2, 2/2, 3/2, 4/2. Okay. So for the next one now, you can go ahead and say, okay, ready? You can go ahead and do this. Say, all right, color in all of the pieces, okay? We'll have them go through and color in all of the pieces. Again, this will be an easy one for them, okay? And you're going to say, well, okay, how many do we have? Well, 1, 2, 3, 4. We colored in 4. And each one of these we know is a fourth, and 1/4, and 1/4, and 1/4. So I have 4/4, okay? Now, after you do this one where they have the whole, go ahead and have them erase it, because this is one where they're gonna learn something different, okay? And go ahead and say, okay, what I'd like you to do now is go ahead and color in one piece out of each one of these now. Go ahead and color in one piece out of each circle, okay? So color in one there. And remember, don't say color in 1/4 of each circle, because that would be giving them the answer. So it's just say color in one piece out of each circle, okay? Okay, now think about it. Think what we just did, right? We just had 4/4. What do we have now? Again, let's take a look. We have 1, 2, 3, 4. We have 4 pieces, right? Now, a lot of kids are going to be tempted to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're going to think this is 4/16. But remember, each one of these is a whole, right? So we have a fourth here, and we have 1/4 here, and we have 1/4 here, and we have 1/4 here. And again, 1/4, 2/4, 3/4, 4/4. You also go ahead and say, look, if we go ahead and we put that piece there, and we took this piece and put that piece there, and we put this piece there, you'd also have your whole. So remember, you can have all the pieces together to make a whole look like that, or you can have the pieces separated. And when we get into mixed numbers and improper fractions, which is what we're doing, we're trying to set them up to have success with mixed numbers and improper fractions, all these skills will come into play, okay? And then you can go for the third set now, or the third numbers, you can go ahead and say, okay, go ahead and color in, say, 1 right here. And then maybe say, go ahead and color in 2 right here. And then go ahead and color in 1 here. And then go ahead and color in 2 here. And remember, go back to the fundamentals, all right? Remember our numerators, how many do you have? 1, 2, 3, 4, 5, 6. We know we have 6. Now we have to figure out, what did we just count? And again, some kids are going to be tempted to count all those. Remember, these are all individual wholes, so all these pieces work together. So we know that, okay,
If these are wholes, this is a third, and this is a third, and this is a third, and this is 1/3, and this is 1/3, and this is 1/3. So how many thirds did we end up having? So what did we end up counting? We end up counting thirds. So we know we have 6 thirds. And again, you could go ahead and say, look, we could take this piece and put that there. We could put that piece and that there too. Just showing them that you can rearrange it, and it doesn't matter the difference between the pieces or not. That's what it is, okay? All right, and then there's just one more model. I'll show you. And again, it's the same concept, just different models here. And by now, they should be pretty good at it. And you can say, all right, ready? Go ahead and just, you can, remember, you can have it structured where you're telling them, this is what I want you to shade. And you say, okay, go ahead now. I want you to shade in a couple. You can't color in all of them. Color in a couple of each one and tell me what you have. So if you go ahead and do that. And then once they do it, they have to go through and say, okay, how many do you have? 1, 2, 3, 4, 5. I have 5. And then what did I just count? Well, each one of those, well, there's 4. They all work together. So this would be a 4th, and this would be a 4th. Okay, and that's just it. And so that one's about 6 minutes long. But that's what you can expect when you click on those lessons for that, okay? And that's just what it looks like. It's 5 or 6 minutes long. Most of them are actually, that was a longer one. Most of them are usually 3 to 5 minutes long. They'll just show you, what you're expected, what to do, how you can do it as well. Okay. Now, just to show you the range of this, right? So if you think about what we had for Hannah is she's going to be in domain 1, one of the most basic ones. Well, Maggie is another student, and her skills deficits didn't really start to show up until all the way to skill 24. So again, if we look at her and look at what she would be looking on, skill 24 has to do with multiplying and dividing fractions. And so there's the activities that go with that. And then there's the practice piece, and there's even story problems that go with it as well. And this is just, we're not going to go spend a lot of time on it, but this is, just so you can visually see. Okay, skill 24. So this is what, it looks like with what you're teaching her to do. And think about the difference in the range that this program has and what it's teaching her to do with is multiplying those fractions compared to what we were just doing with Hannah, which was literally counting by fractional parts with numerators and denominators. So there's a large range in the program too of going from skills that are really 3rd grade all the way up to, 5th and 6th grade skills, and making sure that they understand conceptually what they're supposed to do. Give 1 second, and going through and teaching you how to do those activities with them. Okay. And then the last one we'd go through is if you take a look at Sam. And again, she kind of had her profile is really interesting. If you take a look at skill 1.1, 1.1 and skill 3.1, those both have to do with number lines. So she just had a little weakness with number lines, something that can be addressed really quickly, and counting by fractional parts. Again, this is not a major intervention. She just has a couple little target areas that we need to work on. And then the big thing too is domain 2 is hard. She was able to get through domain 2 without a lot of problems, right? And then again, in domain 3 is probably where majority of her intervention or instruction would occur, because a student who is strong in domain 2, but they just got stumbled by the number lines, counting by fractional parts, that's going to be addressed and solved really quickly. And then for her, when you get into that domain 3, which is generating equivalent fractions and working on the lessons that go with the equivalent fractions, this is what it would look like for her, an instruction for the introduction to equivalent fractions. Through partitioning to the mathematical process. So and what fraction do we have? And we're gonna write it. We have 1/2 right here, right? And I just want to show you something. All right, if we say we were to cut each piece in half like this, that piece in half and that piece in half, and your students have up to this point they've been able to do that. So we know now that what we have is we now have 2/4. So we know that 1/2 is equal to 2/4. And now what we're going to do is we're going to look at the what we actually were doing so we can connect this to the mathematical operation. So if you think about it, if we cut each piece in half, we're going to go ahead and write we cut each piece in half. So what we did, we multiplied this fraction by 1 whole in the form of halves. Now remember,
2 halves is the same as one whole, right? So yes, we are getting more pieces, right? We're changing the amount of pieces, but the amount that's shaded in green is staying the same. So even though we're multiplying it by one whole, we are still essentially keeping the same amount that we had, all right? So if we cut each piece in half, we have to multiply by halves in the form of a whole, all right? Let's go ahead and try a different one now, okay? So let's say we have 1/2 right here, and say, all right, we're going to partition each piece into thirds, right? So we'll cut each piece into thirds. So thirds there. We'll cut this piece into thirds there. And we know that we have 3/6, right? Now remember, if we partitioned each piece into thirds, what we essentially did is we multiplied by thirds in the form of one whole. So we had 1 times 3 equaled 3, and 2 times 3 equaled 6, okay? And again, you could go ahead and say, okay, let's take a look at this, right? If we have 1/2, and say I made no changes, and I multiplied it by one whole in the form of 1/1, I would go ahead and I would still continue to have 1/2. That's exactly what we have. And remember, we're making equivalent fractions. So the amount that's shaded green or blue or yellow is always going to stay the same, right? It's just the pieces that are changing. And we're changing those pieces by multiplying that fraction by a whole in the form of whatever we do. So let's go ahead and take a look here. Again, if we were going to look at 3/4, so we'll put 3/4 right here. And if we were to partition each piece in half, we're going to go ahead and write half right here. So I'm going to cut each piece in half there, and there, and there, and there. We know that we have 6/8. And again, if we cut each piece in half, we have to multiply by halves in the form of one whole. So we know that 3 times 2 equals 6, and 4 times 2 equals 8. And that's how we did.
Okay, and again, that's just another sample lesson of what another sample of what the activities look like when you go through it. Okay.
So when we talk about implementation now, how the fractional reasoning program is used is it's going to look different depending on who's using it. If someone's a math specialist or a math interventionist and your job is to focus just on a small number of children, or the bottom 5 or 10%, it's going to look differently than if a classroom teacher using, or if a district is implementing it on a district level. So if you're a math specialist or math interventionist, you're going to be giving all of your students this assessment, right? And then based on how they score on that assessment, you're going to go ahead and design your lessons and follow the program and fill in exactly what needs to be done. Now, if you're a classroom teacher, you're not going to have the time. I mean, if you do, it's great, but you're not going to be able to test, 28 or 30 students. So what you need to do is, if you are in a classroom teacher, you're going to want to take a couple of your students who you know are strugglers, 1 or 2 of them, a couple of students you view as average or the lower side of average, and test them to kind of see where, the bottom part, where a lot of the misconceptions fall for your class. And then what you'll do is, to off of the data from just a couple of students, you're going to say, like, all right, here's a good starting point where I think we need to start for our class. Again, you could just start at skill 1 and go all the way through. And of course, skill 1 and 2 are going to be really easy, but then it's going to keep building and you didn't miss anything. But you can go through and test a couple of your students, get a good feel for where you want to go. And then you can go ahead and go to skill 6 and skill 7 and skill 13 and skill 20 and 21. Okay. You may be thinking, well, I'm not going to have any data though, because the math specialists, math interventionists, they're giving, these tests to all their students. But remember, even if you don't test all of your students, you're doing this more as a class intervention or school intervention, you still have those daily formative assessments where you're going to be able to give those and get data from those as well. So you're going to be able to still track progress and track students, their learning, and most importantly, if they're understanding the concepts too. So just remember, if you're a math specialist or interventionist, you're obviously going to be testing all of your students. If you're a classroom teacher, it's not practical to test all of your students, and even if you did, you're going to see so many different levels from within your classroom that you're really looking at saying, I want to do just a whole group intervention for everybody. And of course, you're going to have your higher students are going to find some of the skills really easy, but then it moves quick too, and it builds and it builds. And while you may start off with, counting fractional parts or fractional pieces, you'll quickly be in the equivalencies and then adding, subtracting fractions too. So that's what it's designed to do. Okay, next one I want to go over to is When you're going through the skill cards, now remember, this is not a scripted program. It's not going to say day one, do this, day two, do this. And it's not going to say you're going to do this lesson for 3 days or 4 days because your students are actually going to determine what you work on from day to day based on, what you're seeing, their formative assessments that you're giving them, those daily assignments, and so on. So one thing is, remember when you're going through the activities and those videos, the videos are 4 or 5 minutes long. Just take a post-it note. On one of the post-it notes, you're going to want to write down sort of your teaching points, your summary, right? When you're going over this card, just write down the things you want to focus on, 1 or 2 sentences. This is not supposed to be a time-consuming thing. It just will help keep you focused on what you're working on. The second one is a lot of times when you're doing practice problems, write down the 4 or 5 or 6 different problems that you want to give, because sometimes you're going to need numbers that work together, right? Especially with simplest form and so on. You're going to make sure that the numbers work. So as you're doing it, spend a couple of minutes, just write down the practice problems, that they're going to do on their practice mats. So so you don't feel like you're scrambling. So that's just my suggestions. Write down teaching points on one, write down your practice problems on another, stick them to, if you print this card, you can stick them to the card, or if you can print the card and just write your notes on it as well. Okay. And another thing too is with the materials that are provided, if you have like the plastic versions of these, that's awesome. So just go ahead and use those. But if you don't, number one, invest in some cardstock. Okay. Go buy the thickest cardstock you can buy. And the second thing is laminate them. And find the thickest laminate that you can find. And sometimes even if you have to go to like an outside place, go to it. Spend just a little bit of money so you can have these so they last. If you just run them on regular paper and you hand them out, you're going to be cutting these out and making these all the time. So I suggest invest in good cardstock, get them laminated as thick as you can. Also, don't let kids cut these out because even though they're fourth or fifth graders, some of them are not the most coordinated with scissors. Have a parent volunteer or cut them out yourself. It's a lot of work at first, but then you have it forever. And the next thing is do not let them keep these in their desks, right? You will spend all this time, even if you do cardstock and get them laminated, if you put them in your desk, you know how some kids' desks can kind of eat things up. So have a separate, buy some Tupperware or have a place where you can store these, where you can keep these and then pass them out to students and keep them. The last thing that I want to focus in on is when you are going through an instruction, we didn't talk a lot about this, but remember every lesson really kind of within layers of it, there's a concrete, a semi-concrete, and an abstract or representational. We always want them to introduce things in a concrete way, go to semi-concrete, and then go to abstract. One thing to just be aware of is sometimes we fall into this trap of only letting our kids use these manipulatives, which is great, right? That's what we're supposed to do. But remember, when you're using manipulatives, they can become a crutch and they can come dependent on them. So remember, have a plan. If you're going to use the manipulatives, which you should for all the early lessons and early activities, and then have a plan to go ahead and scaffold and take that away. And the program does a really good job. If you watch the lessons, this changes that it makes. It almost kind of forces you to do that. But just be aware, and this is just if you want to go ahead and pause this, and I'm not going to read this to you if you want to pause it and read it. It just talks about when models are used like calculators, what happens, okay? And just talks about the benefits of using manipulatives, but also having a way to take them away. The last thing is procedural versus conceptual. And several research studies have found that one of the critical mistakes that teachers make is there's too much emphasis on procedures instead of focusing on the concept. With fractions, particularly, a lot of teachers spend almost all their time working on the procedural and very little on the conceptual. Where I view the fractional reasoning program as really a balance between the two, but really conceptual heavy. And then when you get into procedures, making sure they understand what's actually happening. So just make sure that when you're doing this, you are, doing the program, going through each activity. Every activity changes a little bit from the one before. So making sure that your kids are really getting that conceptual learning. What is next? Okay, so we're almost at the end of this webinar. And the next two things that are going to be coming out is one, we have partnered with some literacy consultants, and our goal is to make a dual literacy and numeracy intervention for K1 students, where it'll be one intervention with reading integrated with numeracy. As for when that's going to be ready, we haven't even met. We're not meeting until June. So this will take a long time, but we're very excited to do something with this. And the reason is because so many students who need a literacy intervention also need a numeracy intervention. And if you can have one program that balances between the two, where they're reading and then they're counting, then they're going back, it's going to be better for students. And the next program part will be decimals, ratios, and percents. And that will focus on 5th to 7th grade. And that's going to be a while before that comes out. Some of it was developed because this was almost going to be called the fractions and decimals program, but it was just too much to put into one program. So this will be a separate one. Last thing we ask before we show you how to get the materials is please spread the word. We don't do really any marketing or advertising. Most people find us through Google or on social media. So if you want to, please, if you view this training and you feel like it's really beneficial, please post it. Please feel free to share it on Facebook or Twitter or Pinterest or Instagram. Or if you even want to email people who you know, feel free to do that as well, because word of mouth is the most powerful way of advertising, especially in education. So if you can please share this with people, we would really appreciate it. So now what we're going to do is I'm just going to show you where you would go to get access to your materials. In one more minute, I'll show you how to get your materials. But if you have any questions or comments or concerns about anything, just please email info@numeracyconsultants.net. And your questions will be answered. So,
okay, and here's how you get your materials. You would go to numeracyconsultants.com, and then what you would do is you go to the very bottom. If you've watched our other webinars, you're going to know how to get there. You go to the very bottom of the page, you're going to see the copyright in blue. You put the mouse on the copyright, you click on it, and then you're going to be in a folder. It's going to say primary numeracy intervention materials, multiplicative thinking program materials. If you are watching this fractions one, you're not aware of the other two programs. This is the materials, but obviously you need to watch the training so you know how to use the materials, but the fractions are right here. Then you'll go ahead and you'll click on it. And here's the materials that you will receive today. So first I'll show you this part because we haven't done a lot. These are all of the standards. Each skill is put into standards. So once it opens, which is hopefully soon. Okay, I'll come back to this. Hopefully that'll open. So the one thing is when you go through your leveled skill cards, which is right here. Oh, there it is. So when you go through, what you get is you get domain 1, skills 1 through 6. So these are all the lessons. Those are all the materials that go through with skill 1 lesson all the way up to 6. And remember, it's not just 6 lessons because there's a couple different activities for each skill too. So you can go through, and those are all the materials that you'll need for the first one for that. Okay. The second part is you'll have the fractional reasoning book, and the fractional reasoning book, which is going to take a minute to open up. It seems like this too. So we'll give it a minute. Oh, and of course, right as there it is. So the fractional reasoning book, and it's going to give you the first 3 skills. So though the lessons will give you up to 6, when it comes to the workbook, you'll get all the materials for the first 3 skills, which has to do with, skill 1, skill 1.1, and skill 2, which has to do with counting by fractional parts. And then so to give you a good feel for if this is something you're interested in using, it'll have all those materials there. The last part I want to go through for here is the standards. And so the way that this document is broken down, it literally has the standard, the skill, and then it'll tell you the standard that it works on. A lot of skills work on multiple standards. If you see the green, what it means that skill either partially works on it, or in the instructional materials is completely covered through there. So the skill may be not covered directly in the assessment. When you get to skill 2, activity 1, or activity 2, or activity 3, it will go through all those different ones. And so again, it starts off, the lower skills tend to be in 3rd grade, then it kind of goes to 4th grade and works its way between 4th and 5th and so on, and goes all the way up to the very end. Okay, so that document's in there as well. The assessment is here. So you are able to go through the assessment and get the assessment there. There's nothing in this, but in another month when there's time, this enrichment folder will be filled with probably 15 to 20 different enrichment type activities. They may have little videos to show you how to do that as well, but things that'll help with fraction sense as well. And then we have here You obviously have the order form, which will pop up in a second too. So if you use this and you like the program, the parts that are given, you always can purchase the remaining parts of the program. The assessment will always be free. The enrichment part also will always be free. So if you're interested in just buying a single license for the 3 through 6 fractions, is $110. If you want to purchase it as a bundle with the other 2 programs, it's $285. Then for individual schools, $850 for a single license for fractions. Or if you bundle it with all 3, it's $1,500. And then a district license, it's $550 per school for a district license for either one. And if you bundle all of them, it's $1,000 per school. So, all right, we are now done with this training. Again, if you have any questions, comments, concerns that you want to ask, you can always go to our website, numeracyconsultants.com. If you click on contact us, that's our contact information as well. If you need a W-9 for ordering, and periodically too, now if you've registered to watch this, we have your email address. So we're going to try to every 6 weeks do like a free Zoom, which will people can come and ask questions who are trying to implement the program or thinking about getting it. So you'll get an email just saying, the next one will probably be in June or July. It'll just be a question-led one where I won't have an agenda. The agenda will be set by people who are asking the questions. So thank you for viewing. Check out our other programs as well. We also have intervention programs. We have the primary numeracy program, which comes with a ton of free stuff as well. And so does the multiplicative thinking webinar. So, all right, I'd like to thank everyone for viewing, and thank you. And also please spread the word to people who may be looking for math interventions and are looking for a program that provides a lot of free resources as well. So please consider sharing. So thank you.